We want to find a vector equation or vector valued function that represents the curve of intersection of the paraboloid z equals 3x squared plus y squared and the surface x equals e raised to the power of y. Our vector equation or vector valued function will be in this form here, where x of t, y of t, and z of t will be the x, y, and z components of the vector valued function. So we want to define x of t, y of t, and z of t so that they would satisfy both the equation of the paraboloid and the equation of the surface. Let's first look at this graphically. Here we see the graph of the paraboloid and the surface. Again, our goal is to find a vector valued function that would give us a curve that would trace out the curve of intersection. So going back to the equations of the paraboloid and surface, notice how the equation of the paraboloid contains 3 variables, but the equation of the surface only contains 2. So we'll first define x of t and y of t so that they'll satisfy the equation of the surface x equals e raised to the power of y. And it's important to recognize that our vector valued function r of t is not unique, but probably the simpler the better. Notice for this equation here, if we define y of t as simply just equal to t, then that means x would be equal to e to the t, so we can define x of t as e raised to the power of t. If we define x of t and y of t in this way, notice how these will satisfy x equals e raised to the power of y. But again, these are not unique. And now looking at the equation of the paraboloid, since it's already solved for z, it makes defining z of t pretty straightforward. If z equals 3x squared plus y squared, and we want to define z of t, so this equation will be satisfied when we have y of t equals t and x of t equals e to the t, we can just let z of t be equal to 3 times x squared, where x would be e to the t, so we'd have e to the t squared, and then plus y squared. Notice here y is equal to t, so we'd have plus t squared. Let's go ahead and simplify e to the t squared. When we have powers to powers, we multiply, so we can write this as z of t equals 3 e to the 2t plus t squared. And therefore, a vector valued function that would represent the curve of intersection, again, would be in the form of x of t equals e to the t, y of t equals t, and z of t equals 3 e to the 2t plus t squared. Let's go ahead and verify this graphically. This graph includes the red curve that will be traced out by the vector valued function. Notice how this red curve does trace the intersection of the paraboloid and the surface. Let's go ahead and change the window here. Again, notice how this red curve, traced out by our vector valued function, does trace the curve of intersection. I hope you found this helpful.